Good morning. My name's Lux. Thanks for coming out this morning after the big parties last night and flights this afternoon. Just real briefly about me, I'm a retired colonel from the Air Force, flew fighters most of my career, but around 9/11, I got moved to UAVs. The Air Force called them remotely piloted aircraft, and then stood up the first armed UAV squadron in that area, and also got involved with cyber operations later in my career. If I could get a feel from the audience so I know who I'm talking to and hopefully can shift this briefing to who you are, how many are wanting to be users of UAVs in their business? Okay. How many are kind of manufacturers or data-driven type companies that are going to provide services in this area? Okay, and what am I missing? Who's currently licensed? And users or operators? Okay, well, good. The goal of this brief today really is for you to see what we are working on at ASSURE. I'm going to talk about what ASSURE is, but basically we are the regulatory arm of the FAA, a research arm for informing regulation and policy for the U.S. government and the FAA. So you can kind of see, and I can talk about, especially in question and answer and discussion, where the FAA is, and so you understand where the risk is and where it's time to start making investment to move out and to have success and maybe be even one of the first to market. So this is what I'm going to go through just briefly about ASSURE so you understand who we are. We're always looking for partners to work with. I'll go through the FAA strategic roadmap. Most people have seen this by now, but I want to make sure you see how the FAA is thinking. And if you want to adjust that roadmap, that's where you need political pressure on the FAA to make that stuff happen. Then I'll go through real briefly, kind of at a high level of overview so I can move out and leave time for you to come back and ask specifics about whatever research that we're on. And then Duke Energy will follow me, and then we'll have our question and answer period. So why was ASSURE stood up? Well, industry in the early days would go to the FAA with a great idea of what they wanted to do. FAA would say, are you safe? And they'd say, of course we're safe. And well, show me. Well, what do I need to show you? And it was bring me a rock. No, bring me another rock. And this went back and forth with no really good success. So ASSURE out of Congress was the center of excellence for the FAA's drone program, was competed out and stood up where the ASSURE universities that I'm associated with won. And what we do is we work with industry, your user profiles, your technology typically, your IP expertise, and a lot of times your resources. And we provide third-party research on people, systems, and operations and provide data, the knowledge, information, and recommendations so that the FAA, through the regulation standards and guidance, actually then provides access to the national airspace to go do your job. And we'll talk a little bit more. But that's kind of, and how the tasking flows to us is both from the FAA and from both industry. And we tried to build the requirements of what we do with the FAA. Long title ASSURE is an acronym, but basically you can think of us as the academic arm of their research for UAS. When we work, we have two funding vehicles that we work through, primarily grants. You can see on the bottom, we've been funded about $14 million a year out of Congress. And with that, though, it's a one-to-one cost share, so it's double. And we've been executing in the last couple of years about at $30 million a year in research. We also have IDIQ contracts where cost share is negotiable, and we work very specific problems for the government. And then if you're a government agency, you can get to us through the FAA and let the FAA project manage. Really, our success is our team. 23 universities. I just throw these up there for you, led by Mississippi State University. A very strong, different backgrounds, and also a lot of political sway. So sometimes industry will come to us and we'll work research requirements with that company into the FAA through Congress to apply a little bit of pressure in areas of need. The FAA has its pace, its concerns that may not align very well with what's reality out there. We also, in our affiliates, we are growing worldwide in our applications because different areas of the globe have different priorities. And for example, we'll take Singapore, who I'm working in discussions with right now to bring on it as an affiliate. It's a cityscape. That's all they have. So urban operations is what they do. The FAA is not ready to do any of this stuff in Chicago or Orlando or Miami yet, but Singapore has to. So we're using Singapore to start a lot of that research and then feed the rest of the globe on how to do what works for them. We can't do this without our industry and government partners. Like I said, a lot of the IP, a lot of the drive comes out of our partners. We've also established a nonprofit, different mechanisms to get to us to work for either other government agencies or private entities, commercial applications that takes advantage of all our ASSURE relationships and all the knowledge that we get. So through a single contract, single NDA, we can go out and build ad hoc teams of all our performers and get stuff done. And we have work currently going on with defense contractors and various other contractors supporting different parts of the government based on that expertise. Okay, so break, that's ASSURE. And what ASSURE as the center of excellence, not our ASSURE worldwide non-center of excellence work, we support the FAA first and foremost. So our tasking is not necessarily what's in your best interest, it's in the FAA's best interest. We try to work both sides of that equation, but this is how the FAA thinks. So you look at that chart, y-axis is altitude, x-axis on the bottom is both rural operations to urban, and then also think of time over time. So left to right. And you can see where they are right now with their Part 107 visual operations is basically rural type applications, visual type work. And those little blobs are kind of what are going to be ultimately UAS traffic management. How that NASA is in the process of throwing that over to the FAA to come to ASSURE to establish the standards for performance standards for UTM. Also, there is applications when you look up in Class A airspace, that high altitude regime, where the FAA looks at that as certifying the aircraft, the pilots, the systems, just like they would do any other aircraft in that airspace. Now, that's not well defined yet, and I'll get to that in my research discussion. But they feel that they can do that without any great leap. Now, the barrier to entry is cost and time to get those type certifications, pretty much a Type 135 certification. So as you see, you move across, and then in that low altitude environment, eventually moving much, much more into cities. Cities are highly complex, all kinds of micro weather, GPS bounce, there's traffic pattern issues, so that will be difficult. And currently everything under 200 feet is not on aeronautical charts. So you look at your cities that you're around, there's a crane popping up every single day. How do we track that? How do we work with that? So all these issues will work, and hopefully Singapore will figure it all out for us so we can just grab it and bring it back. The way the FAA looks at their flow over time is operations over people. They put out some standards on that. We are currently in a project. We've defined what those performance standards need to be, and we are going to publish with a company how to get this done through an alternate, what we're calling is an alternate means of certification. The FAA put out something based on 4 years old, and they just don't want to redo it. So they've asked us to do this research with this company to lay out their methodology of how this can actually happen. Expanded operations, that's beyond visual line of sight. Pretty much everybody in this room who's trying to operate UAS needs those two things to happen to be able to do really commercial applications. So we're in the middle of detect and avoid work that will support the standards for beyond and certification for beyond visual line of sight. Key to industry, we know it. Then you got some small app package delivery. Non-segregated operations is actually now not isolating UAS from manned aircraft, but actually going together. And you'll see some of our research there, kind of scheduled operations like that air mobility taxi type operation, larger air cargo, and then passenger transport. These things can shift based on political pressure and how things are actually going in our airspace. So as the center of excellence, our research supports that plan, like I said. I'm not going to go through all our old research. There's a ton of it out there. I'm going to pick up where we are today. Currently got about $8 million going against, we've done previously transport aircraft, commercial air, business aircraft, what happens when a UAV and an aircraft collide. Down in the space that we see a lot of UAVs, you got a lot of helicopters and general aviation. So we're looking at that against windshields and tails and what is the severity of an impact? What does that look like? We're also doing a lot of engine ingest modeling with the fan section to understand what will happen with an engine. Will the engines be able to survive an impact, be able to be shut down? Not survive as keep running. We know you can run up to an engine, throw in a couple of nickels, and that engine is probably not viable. So it has to be able to not vibrate off the wing and safely be shut down. And that's kind of what we're looking. And we're starting to look at some heavier aircraft. One of the ones that I was hopeful for me, when we found in our studies that with operations looking at UAVs hitting humans or hitting an aircraft, a wing, a windshield, a tail, that just a slight off-center, non-center gravity on center gravity hit really decreased the damage and risk. And we were hoping the boundary layer as a UAV would deflect the UAV enough in some of these smaller categories to get that off-center hit and be able to say it's not as bad as we think. Well, unfortunately, momentum being what momentum is, the deflection does occur. It just doesn't happen fast enough. And we do get slight offsets, but not that huge significant offsets that we were hoping for. Okay, a lot of discussion probably everywhere you guys go is data. The FAA has been doing this now for about 5, 6, 7 years, seriously, and the test range is about 4 years. And all that data, they don't know what to do with it. They have these state pilot programs, all kinds of stuff, and there's no standard format of that data, so they don't even know how to cull through it. So we've been tasked to do that. So we are establishing standards of data and ways to aggregate data. If you're a company that has some new idea, we can hide your trade secrets, but still be able to aggregate and collect the data that will inform FAA to make decisions on safety ultimately. So that's all coming. That process is being established. And the end state goal of this is until certifications are all established and you go for a waiver, you go for a night ops waiver, there'll be data already available on UAS that are already cleared for nighttime operations. So as long as you're one of those systems, you just check that stuff off. So in the waiver process, it saves both the applicant time and then the FAA a lot of time in looking at it. It makes it far more consistent across the board. Okay, the integration piece, detect and avoid. Heavily involved in detect and avoid systems right now. And what the goal of this is to define the performance standards for detect and avoid, and we're getting close there. And then the means to certify that you can meet those performance standards. Everything from more expensive flight tests to less expensive maybe modeling type operations or margins of safety that are really large to pull it off. We're doing a lot of work collecting, and all that data work we're doing, we're pulling everything together, and we have metadata specialists, librarians now on data, looking at all that, crunching all that, and trying to figure out what does it tell us? And then how do we establish for different types of operations, different types of airspace, what are the levels of acceptable risk that you got to show as a company or a pilot going to operate in any of these different types of things. E-commerce is a look at e-commerce and the networks that are going to flow from the Amazons, the Walmart warehouses, and some of the things we've talked about. So the FAA can have a system. It might not be perfect, but it's a model that they can start developing airspace and changes in the way they manage air traffic around UAS. Things that are about ready to start. I'll start on the bottom here. Multi-aircraft control. Another thing that's very valuable to industry is the ability for one pilot to control multiple aircraft. So a classic example of this would be potentially in the future, those airliners going across the Pacific or the Atlantic, all lined up, flying the same route, 4 or 5 of those. And, can that one pilot manage all those aircraft since they're flying it? And that'll deal with autonomy and mission load. And we're trying to figure out what those key variables are. That airspace data stuff, that will be the simplified methodologies for you to be able to actually get waivers and in the future get certified for operations. Now, moving into applications. At top one, disaster prep and recovery is huge. Congress has laid on us $6 million, of which we got to match at $12 million in research with FEMA, with state, local, and governance, various agencies to look at how the FAA, well, first, where does UAS have an application that's better, faster, whatever? And then how do we get that integrated? And how do you turn on and off airspace quickly and integrate these things in a command and control system? Big, big project. And a sidebar out of this that we are working as not the center of excellence, but worldwide, is the credentialing, the training programs and certifications required to credential anybody showing up at a disaster that it'll be known. So somebody coming into a hurricane who goes to fly a UAV, right now there's struggles because people come to rescue and save the day, but have no qualifications to do that. So that's some of what's happening in there. Just kind of jump ahead. Here's where we're going. The FAA originally thought we would never use UAVs around airports. It's come off of that. We are working that. What is the signage requirement from taxiing to takeoff? What does the departures look like? What are the speed restrictions? What are the different pattern requirements? And then the same thing on arrivals. How do we deal with that? Wake turbulence, again, some of these smaller UAS are used to inspect some of our airliners now, or air cargo want to use UAVs to do a lot of their aircraft inspections after flight. They can do it a lot quicker that way, but there's concerns that these things flying around on the ramp might be affected by turbulence. So that's the start, but turbulence can affect us in so many other different ways. Think of those urban ops when it's flying through the city, hits across street with the wind blowing down it. So that'll establish a lot of that kind of studies. Cybersecurity, big deal everywhere, right? We've probably been talking about it in every single room in this conference. Well, one unique thing about UAVs is potentially you can lose link of one of these things, right? And you want to be able to get it back. Well, that getting it back thing is also a way to hijack your UAV. So anything with an aperture to receive data can be hacked, can be grabbed, can be stolen. So we have to work through the different risk, and figure out when we want it to be really much more of a closed system versus something where we just don't want it's more of a use for hobbyists, where we want them to be able to regain control quickly. Counter UAS it goes along with that around airports. We've been approached on how to do that. There's a lot of law in place that will need change and different policies, and we're working through that. Air mobility ops, that's that city. How do we, in congested areas, move people and cargo around a lot better? This is a start. This is a survey to figure out where does it make sense? What are the break points? What type of applications could be there? What is the business case and thresholds associated with that? So the FAA has an understanding of how quickly this can happen in the United States or not. And then one of the things that's been the bane of my existence for the last year is there's one congressman who wants a full engine ingest, and apparently we're going to do one where we run a UAV down through an engine, which is going to piss off all the engine manufacturers that I'm using on the modeling, because it really doesn't tell us much, but they want the event. I'm trying to keep it from being just a freaking YouTube sensation. We don't know what it's going to do. It doesn't matter because it's a test of one. Even if it validates all our modeling, I can't use it. Or if something goes a little different than a model, it doesn't disinvalidate it, but it's a big political kind of show. Where we're moving, this is big. This is the bins of certification. The FAA sent out a note, I think notice 2 days ago. We have our research proposal into the FAA of what are the bins for certification for UAS. How we're going to try to get those things defined based on some variable that is not clear to anyone yet. And then here are your bins that you're going for pilot training, for operations, for equipment. So just like we have in manned aircraft, these things will be defined. You know which bin you're going to be in. You can actually now have a set path towards certification for those. Okay, as we move forward, as I mentioned, like with Singapore, we are increasing, and we've been asked by the FAA with no real authority to collaborate and coordinate to the best ability that we can international research. They formed a regulatory roundtable that meets at least once a year, and there's phone calls about quarterly, and they talk about their issues and try to make horse trades on who's doing what and how things are going. And then I'm out there trying to find universities and researchers that we can work with around the globe to pull that off. And then that training and certification bit for first responders, big deal. We're looking to take on, we're in discussions with various companies, AT&T and others, to try to figure out how to put this thing together. So just kind of walk off the stage stuff. We're executing about 30 million a year. So there's a lot of money trying to lift the veil of regulation risk off you guys a little bit. It's not happening fast enough in my book, but if you have questions, feel free to reach out. You can find us by our website that keeps popping up in the bottom corner. Come talk to us, and we'll let you know where we are and put you in touch with the researchers and then favorable individuals within the FAA that are trying to drive things forward versus the culture of no. Our brand's growing internationally and all around, and where we're making progress is ops over people, so that there's now a methodology for you to get certified to fly over crowds of people. Detect and avoid, that's probably got about another 6 months till we finally publish what that will look like, and then we have to get acceptance by the FAA. The way we define and collect data, that's moving along very well. Matter of fact, on our projects that are coming out now, we're using that methodology and fleshing it out in all the details. And then what I put there, we're moving into airports and certifications. We got a lot of work to do. We're always looking for partners to help us through that.